In this tutorial, what we're going to do is look at the way in which we can use a multimeter, and we're actually going to see how that works on Circuit Wizard, so you can get a few ideas when you're designing your own circuits and troubleshooting, and you can use the computer to help you out. So as you probably remember from looking at this, the actual circuit itself doesn't really do anything. It's just there to get you used to soldering on link wires and fixing tracks when you break stuff and things a bit like that. So at the moment, if I actually try and play the circuit while it's loaded up in Circuit Wizard's actually going to complain. And the reason it's complaining is because component IC1, which is this picture just here, I've not actually really said what chip it is or how it's set up or anything like that. In reality, as you perhaps know, there is no component ever going to go on there. It's just to get used to drilling holes that are close together. So if I'm going to have any success, one of the first things I'm going to need to do is to click on that once and then just push the delete key to delete that out of the way. The next thing I need to do as well to modify this circuit diagram is, oh hello, it's meant to be a 0. There we go. Anyway, the next thing that you're going to want to do as well is we're going to have to stick 4 more pads actually, onto the circuit. These things here are pads, and the reason for that is in a little while we're going to connect up our very own virtual multimeter, which we can find in this shopping cart. But when we do grab the virtual multimeter, what we're going to need to do is to tell it whereabouts we want to touch the little probes. Now, obviously in real life, what you can do is you can just grab the wire and touch anywhere you like, but in Circuit Wizard you've got to make sure that each probe touches a pad. So we're going to click on the pad tool just here. I'm actually going to double click on it first of all, and I'm going to change the, and if you double click this comes up, and I'm going to change the default pad from, this is in inches, that's okay, it doesn't matter if it's metric or inches, but just basically make it so it's about 3/4 as big as it is at the moment. The number's not important, but it just needs to be a bit smaller, so I'm going to go for 0.7 by 0.7, a bit like this. Okay, looks like I made a bit of a typo just there, so I'm going to delete that and double click on the pad again. And I'm going to try and go, I put 0.7, I made it huge, didn't I? It should be 0.07. There you go, this is why I don't teach maths. Okay, and there she goes. Splendid. Let's try that. Now the pads need to go just here, above where one of your fixes is going to go. Just here, just below one of the points where you're going to do a fix. Just here on the other end of that fix, and just here on the other end of that fix. Just make sure that the circles don't touch anything else, because you might cause some shorts down the line, and you don't want to do that. Okay, so what we can now, I need one here as well actually, look, on this link multi, let's stick one in there too. Blip. Lovely job. Okay, so what I can do now is I can actually do some of the soldering lessons myself. I mean, Circuit Wizard, if I click on Real World View, Circuit Wizard's already got my resistors on, and it's got that diode in there that we include, but it hasn't put in the fixes, the track repairs, or the pieces of link wire. So what I'm going to do is add those in now by going a bit like this. Doesn't matter which view you've got, I'm actually going to flick it back to unpopulated, just because that's how I like to use. I'm going to click on Project, and I'm going to scroll down to PCB components. Then I'm going to go to flying wire, which is this just here, and I'm going to click on that. What I'm then going to do is draw a link wire from the top of that fix to there. Actually, no, you click and drag actually. That's it, click and drag. There's my first link wire drawn on. I need another link wire just here. Actually, that was a track repair. Sorry, it doesn't matter, it's all the same. Over the fix here, I'd be using a piece of wire soldered across to fix that, and another piece dialing across here as well to link those two together. So pretty much what we've got here is a version of the soldering license, albeit with that chip carrier missing. So what can we do now to actually get an idea? Well, one of the things, I do this in the video tutorial for the practical work, I figured it's going to be easier for you to see me do it virtually. What I'm going to do now is grab a multimeter. So if you go into the gallery, go right down to the very, very bottom. And the last item, it says test equipment, you'll see it says virtual instruments just here. And there's some various different ones that you've got in there. And the one I'm interested in is the digital multimeter. So I'm just going to zoom out, roll the mouse wheel away from you, I think. Click on digital multimeter, and sort of click here just over to the right hand side. That multimeter's now popped up. As you can see, it's enormous compared to the circuit board. Okay, so with our multimeter, what we need to do is to connect up the multimeter probes, just like you would on a real meter. I'm going to try and zoom in a bit. What I'm going to be aiming to do here is making it so I can read the display on the meter and also still get to the probes down at the bottom just here. This hasn't got as many features as the multimeters in school, but that's okay. We can do the main ones that we want to just here. And the main thing we're going to be using is this resistance section just here. Let's first of all start with a simple check, and let's check that our 330 ohm resistor here, let's look at how much resistance is flowing through there. So you've got your common probe, okay, now you always use that one. So I'm going to grab, click and drag here, look, as I do that you can see the outline of a probe starting to stick out. I'm going to pop that one at the top of the 330 ohm resistor. Doesn't matter if you stick it below, it's a resistor, they're not polarised. I'm going to click and drag here to spin it around a bit so I can sort of see what I'm doing slightly better. And I'm going to go to my sort of live probe, which is this one here, that's used for measuring voltage, for measuring milliamps current, or for measuring ohms, which is resistance. So that's the right probe for the job just here. And I'm going to drag that and pull that and throw that on there like that. And again, just spin that around a bit like so. So my probes are now touching either side of that resistor just there. All I can now do is set the resistor at the multimeter to whatever setting I want. We've got alternating current voltage, which you'll never use in school because that's mains voltage electricity. I've got measuring current. We're not actually connecting a battery to this circuit even, so there's no current to measure. You've got direct current voltage, which is this one just here. We're not measuring that because again there's no battery. We don't need it turned off, and the ohm symbol represents resistance, so it's going to be one of these. Now, as you might remember from before, or maybe you don't, when you've got a multimeter, what you want to do is to dial the multimeter to the next biggest number after the one you're expecting. Okay, so what do I mean by that? What I mean is, this is a 330 ohm resistor, and so is the number 200 bigger than 330? No, 200 is definitely a small number, so it's not 200. Okay, 2k, 2000 is 2000. A bigger number than 330. Yes, it is, so that's the number there. So what the number means is it's the biggest amount of resistance that particular setting can measure. So 200 wouldn't be right for it. So I'm going to leave it set there. Let's click on play and fire the circuit up. Plop. And straight away, what I'm seeing here is I'm getting told that we've got 330 ohms of resistance in this circuit. If I did dial it to 200, what I'll do is I'll see a number 1 up here instead. You'll see that in any multimeter that you get. And what that is the multimeter saying to you, I can't get a reading. I can't read the level of resistance because there's more here than I can deal with on that setting. On 2K, you'll see 330. On 20K, so we're going from 2,000 to 20,000. Okay, so that's the maximum amount. But bear in mind, you've only got this sort of 3-digit display here. I wonder what that's going to say to us instead. Well, I'm pretty sure in my head it should say 33. Let's have a look. Or 0.33 actually. Okay. So what it's saying this time is that's telling us 330 ohms. You can turn it up one more. That's telling us 330 ohms as well. But again, you get a much more accurate reading the closer you get to what you want. Okay, let's let's stop the simulation and try a bit more probe work. I'm just going to zoom in temporarily over here. Okay, let's move one of our probes by clicking on the tip of it, and this time I'm going to leave the red one where it is, and I'm going to move the black probe, and I'm going to stick it just, it's the spinning it round tool, I'm going to stick it just here, like that. Okay, now I want you to think really carefully, and have a little guess, because this is how you kind of learn about electronics and stuff, is by trying to guess the result. We've got here, let's turn my head sideways, I've got 330, I've got a 2K2, so 2,200 ohm resistor, and it's also touching the bottom of this 470 ohm resistor, so we've got wire either side of it. How much resistance do you think I'm going to be reading this time around? Well, the answer is, let's imagine the flow of electric current through here. So we've got nothing at the moment. We flow through here, that's 330 ohms of resistance. Flows through this track into the next one. We add another 2,200 ohms of resistance, so that's 2,530 ohms. And then we get to here, and we haven't passed through this resistor yet, so it's 2,530. That's what I'm expecting. Let's go and see what our multimeter thinks we've got. I've got to stop being so pedantic about my zooming. There we go, and action. So I said 2,500, didn't I, right? Okay, so given that this can't go past 2,000, I've got to turn it up to the next setting. So let's have a look. 2.53, so that would be 2,530. Ta-da! Just like that, you see? It's clever, isn't it? But what you, of course, are going to understand is that as we crank up the accuracy, this time I can see 2,500, but I can't see the 30 because we've run out of decimal places. And that's why if you want to be accurate, it's better to set the meter. It's the most appropriate thing to read it with. Okay, one more of these, then we're going to look at something else, okay? And again, you'll want to do this with your real board once you get to that point as well. Okay, so I'm going to grab my probe again. I'm going to go right to the end of the resistor network this time. I call it a network because it's just a whole bunch of resistors all chained together. I've actually done the maths for you. I'm expecting this to give me 22,000 ohms precisely of resistance. 22,000. So where do we set this gauge for 22,000 ohms of resistance? We set it to 200, yeah? Because that's the next biggest number, after that. Okay, so let's give that a bell and see if I did any good. 21.0. That's interesting. Looks like I wasn't very good at maths when I did that. So look, 18 plus 2, that can be 20. And I've got my hundreds, 4, 5, 6, 7, 8, 9. Okay, that's not a million miles off. Something I should mention when you come to actually do this in real life, by the way. Let me just double check I've not done anything stupid. That's an 18k. So 470. That's 2.2k. Let's just try 2,200. And that is 330. Oh, maybe it does up to 21. Okay. As you can probably tell, not a great mathematician. Sorry. Okay, so moving on. We've got that. We've decided that that's given us the overall resistance across all those resistors when they're added together. Okay, what else can we do with the meter that's quite useful? Well, one of the things that I quite like is this. We can test the diode. Okay. Imagine, with my version of this, I made one months and months and months ago, and I carry it in my pocket on my keys all the time. And what's actually happened with mine is that little grey band on the end of the diode, because you know the diode, let's go back to real world. On here it's got that little band on the end, doesn't it? And that way you know which direction the current flows through, because it acts like a little arrowhead that you know that current can flow from here over to here, but not backwards, right? We can use multimeter actually as well with the resistance setting to work out which way around diodes connected up, and we do that a bit like this. The resistor, the multimeter itself, the way it works is it sends out an itty bitty little bit of electricity out of this probe just here, and it collects it over here, and based on how much current voltage arrives back here, we can decide what the resistance is. That's the way it works. More details not important, but based just on that principle, I reckon that what we could do is if we tried to take the little bit of electricity that the multimeter provides and stick that on this end of the diode, and we tried then to catch it on this side of the end of the diode on the common probe, and if we turned it down to the smallest amount of resistance possible, like this, okay, then do we expect anything to come back? Do we expect to read anything? Well, no, I suppose we don't, because we're not physically allowing the current to flow from here and back this way. But what if I connect up the other way around? Okay, so let's just delete that one and grab that one and pop that on the other end, and grab that one and pop that on that end just there like that. What if we run it now? 20.7. So this way around, you could use a multimeter to actually tell you which way around a diode needs to go if you ever picked one up and you'd managed to rub the label off it. Okay, and again, we can also see that the diode's working properly because it's allowing current to flow this way, but not to flow that way. So that's something else we can do with the multimeter. The other thing we can use with this setting as well is we can use the lowest resistance setting as a form of what we call continuity tester. All continuity means is continuous, like something that continues unbroken. And a good place to do that when you're doing your board, when you're doing your soldering lessons board, is to actually make sure that once you've finished all these repairs, that all these repairs have worked okay. And the way you can do that is to grab this probe just here and connect that up over here. So what you're doing is you're sending out a small amount of electrical current. It's not going up here because that goes through a resistor network and it's got nowhere to go afterwards. But the electricity will flow down here, along here, over that jump wire, up, around the corner, down she goes, across it'll go, through the diode as well actually, and all the way out the other end. Let's cut the diode out of the equation just for a second, but that should work as well, I think. Let's test that. Okay, we've got a reading of 0, which is a good sign. If we'd got a break in our wire, let's say for example when I did this repair just here, in fact let's be a bit more creative. Let's say that this repair just here was no good. I'm just going to delete that. There you go, it's gone. Let's try that test again. 1. Okay, see the difference? In real life, you wouldn't actually probably get a reading of 0. You'd probably get a reading of something like 0.01 or 0.92, because even copper track itself's got a tiny little bit of resistance. That's not important right now. Moving on. As I was saying, so we can see here that all of a sudden in our circuit, we've got a problem with not getting a reading. So what would I do if I was using a real-life multimeter and holding it in my hands and I was doing this? Well, what I'd probably do is I'd grab the multimeter and move it along a bit, and I'd test again. Still not working. And I'd move my meter along to the next point and I'd test again. Still no good. And I'd move it along a bit and I'd test again. Still no good. And I'd be getting a bit worried about now actually, but nonetheless I'd press on because that's what us engineers do. I'd connect up to the next point and I'd test again, and suddenly I've got a reading. So straight away, what I now know as a electronics engineer is I suddenly know that my problem that I've got must be between this point here and the last point I probed at. And it is, because the wire's not there, because I deleted it. Okay, so that's kind of cool. So we can get that wire back in there. Flying wire. And stick it back in there again. And hey presto, now I've done my repair on my imaginary problem that I just created. I'm suddenly getting a reading again. So I've got my continuity back. So, in summary, what we just looked at there is a whole bunch of different ways that we can use a multimeter. What I'd like you to do is to do the following thing. I would like you to go back and to add all these resistors here, to retest them, like I just did, and to write down what the software simulation says the resistance is at each point, and add another column if you need to in the task sheet that you've got for this. And what I then want you to do is to write down the simulated values and then compare them to the actual values that you get when you connect up a real multimeter on a real circuit and you actually look at what readings you get, because I think you'll find they'll be a bit different. The reason for that, as I think I again explained in the other tutorial, is that the resistors that we've got are what we call 5% resistors. They're expensive ones, they cost like 1/3 of a penny each. But what it means is that if you bought a 100 ohm resistor, for example, then it's all the company is saying is it might be 100, but it probably won't be. But it'll be anywhere between 95 and 105 ohms, so it'll be sort of plus or minus 5% of the value that you wanted. Okay, so I think I've rambled on for quite long enough. I will see you in the next tutorial.